Today we'll be discussing chapter 3.4, applications of linear inequalities. Basically, we have learned quite a bit about linear inequalities, and in this chapter we will discuss how we can use linear inequalities to solve problems in daily life. I will do this by using 3 examples from exercise 3.4, questions 2, 4 and 7. Without much further ado, let's start with question 2. Question 2 is about an examination, okay, where there are 2 papers, and Ali scored 57 in paper 1. The total score has to be at least 120 in order to pass exam. What should he score in paper 2? So first I'll say that let the paper 2 score be X. So his total score will be a score of paper 1 plus paper 2. So first I write down his total score must be greater than or equals to 120 and less than or equals to 200. Can? Because he has a score at least 120 and the total score 100 plus 100 will be 200 because the full mark for each paper is 100 marks. Now next thing we write down 120, okay, paper 1 score 57 plus X is less than or equals to 200. Notice that I have modeled, okay, I have used what is given in the question, what is given in words, I've modeled it into mathematical language over here. And at this step here, it really looks something that is already pretty familiar to you. It will be a simultaneous linear inequality. So I will split it up and then we will carry on to solve as per normal. So now for this part here, I'll write negative X is lesser than 57 minus 120. So let me calculate that. Negative X is lesser than or equals to negative 63. I'll multiply both sides by negative 1, which means that X is greater than or equals to 63. For the other side, X is simply equals to 200 minus 57. X is lesser than or equals to 143. Okay, here is where we will write we will draw all the lines down. Because simultaneous linear inequalities, you have to draw all the lines. So 63 to 143, then X is greater than or equals to 63, like this. X is lesser than or equals to 143, we draw it like this. So we look for the intersection area, or where they overlap. So they overlap down here like this. As we have discussed in class, here we will put it down and we draw. This third line here is my final solution. So the score of my paper 2 should be greater than or equals to 63 and smaller than or equals to 143. Alright, before I actually conclude this question, there's actually something wrong with this inequality here. What is wrong? X represents the paper 2 score, okay, so paper 2 score is from 63 to 143. Then we see there's actually something wrong here because my paper 2 score cannot be 143. So therefore, in order for me to adjust this, okay, so let me write it down, okay, down here, there's something wrong. Paper 2 maximum score is 100. It cannot be 143. So in this case, we actually have to adjust, okay, our inequality to 63. X is greater than or equals to 63 and less than or equals to 100. So therefore, he must score, alright, between 63 to 100 marks in order to pass the examination. So we write a statement down. He has to score at least 63 marks to pass the examination. And that is that for question 2. Okay, basically the difficulty in this chapter is actually how you write out the first inequality. Beyond that, solving by now should come pretty easily for you. I will now do question 4. Question 4. In a chemical reaction, the mass of a product increases at a rate of 11 grams per hour. The current mass is 46. After how many hours will the mass of the product first exceed 101 grams? Okay, so I say let the time be t. Okay, alright, then I can put there, if you want to be more accurate, is t in hours. So we have to form an inequality now. First, I will say mass. Okay, what's the mass? The mass is equals to 46 grams. Alright, plus they say that it increases at 11 grams per hour. So it's 11 grams per hour times the number of hours. So this is the initial mass. This is 11 grams per hour times the time in hours will give you the total mass, right, for at a certain period of time. So in this, they say that the mass will first exceed. Exceed in this case, we have to be careful. Exceed, right, it must be more than 101. It cannot be equals to 101. So I translate it into the mass is greater than 101 grams. So I just write down 46 plus 11t is greater than 101. So therefore 11t is greater than 55 and t must be greater than 5. So to answer the question after how many hours, you can say after 5 hours the mass will exceed 101 grams. I think this question is slightly simpler than question 2. Finally, we go on to question 7. Okay, question 7 works like this. In a model toy kit, each brick is 5 cm long. How many bricks can be lined up in a row so that total length is greater than 28 but less than 40? So I'll say let the number of bricks, you can call it X if you want, but in this case be B. Alright, so now I say number of bricks, okay, length of bricks, okay, each brick is 5 cm, so the total length of bricks is simply equals to 5 cm times B. So 1 brick is 5 cm, 2 bricks 5 times 2 is 10, 3 bricks is 5 times 3 is 15. So alright, 5B there, and they say that they want the total length, okay, total length to be greater than 28 but less than 40. So I say 5B is greater than 28 and less than 40. Now again, another simultaneous linear inequality. I split it up. 28 is lesser than 5B and 5B is lesser than 40. So I say negative 5B is lesser than negative 28. So 28 divided by 5 is 28 divided by 5 is 5 and 3/5. So B is greater than 5 and 3/5. And on the other side, I get B is less than 8. Now again, for simultaneous linear inequalities, you have to draw the 3 lines. So I'll write there 5 and 3/5, okay, and 8. So B is greater than 5 and 3/5, and B must be less than 8 as well. So we look for the overlapping region again. The overlapping region is down here. So in the end, the final answer, or the final solution as represented on the number line, is down here, this third line down here. So I say that B must be greater than 5 and 3/5 and less than 8. So they ask you how many bricks can possibly be in line. So we must have a whole number of bricks. So the number of bricks can be 6, okay, or 7. Oops. The number of bricks can be 6 or 7. So greater than 5 and 3/5 is 6 or 7. And that's it for question 7. Okay, thank you for watching, and we will see each other in class tomorrow to do the work in exercise 3.4.